Now it's my pleasure to introduce Simon Hunt. He's the main developer for the graphical user interface of ONOS. He's also a network expert, but this is what he does for us. And I'll let him present the graphical user interface and also doing a little bit of my demo. A little bit, just a little bit.
Okay, so good afternoon, everyone. You've all listened to a lot of talks. You've had some lunch. You've been sitting here for an hour. I'd like you all to stand up for 3 seconds and then sit down again so that you don't fall asleep in the next 30 minutes, please. I'm serious. You've got to stand up, stretch, and hopefully you'll be awake enough to listen to what I have to say. Okay, there may be some gentlemen who want to sleep. That's okay, I won't call you out. Thank you. Okay. Let's just have a show of hands who have not actually seen the web UI for ONOS. Has everybody opened it up and played with it with maybe a mini-net topology? No? Okay. So I'm just going to spend just a couple of minutes showing you the UI. So I do have running here on a virtual machine a small single node cluster with some switches. As you can, oh, not that one, sorry. It's this window here. I'm going to just do a ping all. As you can see, we've got connectivity between all of the hosts. As I log into the UI, it defaults to the topology view. One thing that I did want to point out here was the map that we have of the UK here, as you can probably tell, that's my homeland, is actually a topo.json data file that we can create a projection which uses longitude, latitude information. So the locations of the switches are actually, what's the word, injected into ONOS. It's into the database, and we're using longitude, latitude, and then computing where on the map they should go. And so we can do this for any region that we have a topo.json map for. And this is the net config mechanism that we were talking about before, where you're defining information as JSON information and then uploading it into ONOS. So I did just want to point that out. So this is kind of, in Avocet, this was the only view that you had. And then over the progressions of releases, we added more and more views. So in the top left here, we have this pull-down menu. And so you can get a different view of, for example, the devices here. And then selecting a device, you can get a little bit more detail, including the ports that are there. And also from this view, we have kind of these buttons here, or tabs, where you can focus in on the flows of a specific device, the ports and the groups, and so on. Now, in this view, we have the line items are one per flow. This is in the collapsed view, but we can expand it so that you can see a little bit more information. We're currently working on adding a detail panel. It's work in progress, but the idea is that in this expanded view, the criteria and the treatment instructions and so on are just strings, text strings, right? And what we would like to do is provide a little bit more structure to that data. And so we're going to provide that in the details panel here. So as with all of the table views, these tables are sortable. So you can just tap on the header there, and this particular view and others, as we add to them, also have a search box, so you can look for a filter by some text to find specific rows and so on. So this is a very, very quick tour of the UI, because I actually want to show you the architecture. What else is interesting in here? So with the intents, again, these are intents that we've injected. They're host-to-host intents, and they were injected by the CLI. there's a command which allows you to just throw in some random intents from host to host so that you have something to demonstrate. And again, if we open these up, you can see that the details and the resources and all that is right now just text strings that we're putting up on here. And again, one of the works in progress is to add, I don't think we've actually done it on this one, but is to add a detail panel when you select one of these to give a more structured output. Okay, so that's probably enough of that. So one more thing is that the big white rectangle there is what we call a view, and each view has a unique identifier. And in this case, this is the identifier here is intent. But an application, when you're writing your application, you can add content to the UI and inject it in at runtime. And so one of the important attributes of your view would be a view identifier. So if you can just keep that in mind, and we will now go to presentation side of things. Okay, deep breath. So there you go. Again, just a quick snapshot. The idea of the web UI is to provide some kind of window into the ONOS cluster, and gaining information about the network. This is actually an older screenshot. If you compare how it looks here to how it looks, oops, oh, it's in the other one. It's had a bit of a facelift in the last release. So the message that I want to get across in the next 5-10 minutes is that adding new content to the UI is fairly easy. We've tried to design this in a way that the burden on the application developer is as small as possible. What you're doing basically is adding Java and web resources as part of your application. You don't have to worry about providing any web bundles or how you're going to communicate with the server side. That all comes available for you. So what you're providing is some Java classes as a part of a component so that it can be loaded into the OSGI framework. When it's activated, there's the activate method that gets invoked, and that's when you basically register with the UI subsystem. If your application is deactivated, again, there's that deactivate method where you will unregister. And at each of those points, the UI subsystem will notify any GUIs that are connected that there's new content or that there's content gone away, and will suggest that a refresh is in order. The static resources, because we're using AngularJS as the framework, to provide structure to your view, we just really need a small HTML snippet, which provides kind of the containment hierarchy of any tables or widgets or whatever that you're going to show in your view. CSS for styling, JavaScript for the client-side behavior. But a lot of this is actually handled in message handlers in Java on the server. And what they do is they basically can get references to the ONOS APIs, the service APIs, for example, device service, link service, host service, intent service, all of those services. You can basically have your, the user will interact with the UI, the message will go down to the server, the appropriate handler will be selected based on the event type. It can gather the information, form it into JSON, ship it back up to the UI, and then the UI can present it. So yes, there's already, no, I haven't mentioned this one. As you saw in that brief 5 minutes at the beginning, there are a lot of different views that are table-based. So the idea of the tables, the layouts, the line items, the columns being sortable, line items being selectable, and having a details panel come out is all part of the base UI framework. And you as a developer who wants to create their own table of information can make use of those libraries and with reasonably small amounts of code, produce your own views. So we have table abstractions that you can use. The messaging substrate is, as you'll see in a moment, is basically a little JSON event. So the JSON has two properties. It's an event type and a payload. And the payload is an arbitrary object structure. We'll get to that in a minute. Another thing that you will gain for free is what we have called cluster failover. So the way this works is that each member of the ONOS cluster is running this web server. So that when you connect, you can connect to any instance and you'll get the web UI. And if the instance that you're connected to happens to be the instance that dies, then the UI will actually detect that and it'll flip over to a different instance in the cluster, hopefully providing seamless switchover to a live member of the cluster. So as I mentioned before, the contributions are injected at runtime. So when your application is activated, it will get injected into the UI subsystem, and when it's deactivated, it'll be removed. So I've already mentioned that you can contribute a new view. Another way of augmenting the UI is to use what we call a topology overlay. What that is it's not a new view per se, but it is injecting new behaviors to the topology view. So actually, if I just quickly dive out of this and go back to, where is it, the web UI. So I go to the topology. If you look at the bottom control panel down here, we have, out of the box, we have what we call the traffic overlay. And when we activate it, what it provides is it can inject its own toolbar button behaviors that are unique to the traffic overlay. And also, it can do things like injecting new buttons on the details panel. It can totally override what's shown on the overview panel. And it can change what's displayed in the details for things. So, for example, with the topology view, let's see, this is dangerous going off script here. But if I select a host and I select second host with a shift click, you'll see now that the traffic overlay code on the client has detected that we've selected two hosts, and it's now giving us an option to, not sure related traffic, to create a host-to-host flow. This is demo purposes only. It's not how we would suggest that you set up flows. But by clicking that button, what we've done is we've sent an event down to the server. The server's gone to the intent service, I think, and then asked for a host-to-host flow to be installed. And then that data is propagated back up, and now we're kind of visualizing that flow. So topology overlays is another way that your application can provide new behavior. Is that, or did I just lose the network?
Is it network or is it?
It says waiting for Google. All right, this is why I did the. This is why I did the backup. Sorry about this. We are going to flip to the PDF, which is not so much fun. And it's also hang on. I do apologize for the slight technical interruption here. So. Oh, that's even worse. You can talk amongst yourselves, think up questions. All right, that's gonna have to do it. Is it back? Might be back. Let's try. Fun presenting.
I think you might want to turn off your Wi-Fi, right? So you're on the dongle, right?
Oh, this guy? That one? No. Okay, I'll just go from here. Okay. So basically, the way the UI is architected is that we have a UI extension manager that implements the UI extension service up here. And in fact, the whole of the out-of-the-box ONOS UI is implemented as an extension. And so at the time that ONOS comes up, the core UI extension registers with the UI extension service. So what's in here is basically we have small Java immutable objects that are tokens that represent each of the different views on the UI. And they contain information such as the UI view ID, the text to be shown on the navigation bar, the icon to be used, and other basic information about that view. We also provide the HTML and JavaScript and CSS for each of the views. And then there's a couple of files here, which we just call glue files, which is to basically tie everything together. So the relationship between the client-side code and the server-side code is a loose coupling based on the UI views. And so the glue files here are basically what allows us to stitch together the index.html to provide the linkage to all of the subsidiary static files. Another thing that a UI extension must have is a UI message handler factory. And the reason this is a factory pattern is because if you think about it, when a browser connects, what we do is, first of all, we promote the HTTP request into a WebSocket. So there's now a two-way bidirectional TCP connection between the client and the server. And every time a new connection is made, what we want to provide are message handlers for that specific WebSocket. So if a second browser connected, we want a separate set of message handlers. So there's usually one-to-one correspondence between a message handler and a UI view. The idea being that this message handler knows how to process all of the different event types that this view will generate. And by event type, I mean it might be, show me the data for this table, or show me the details for the item that's selected. Each specific message handler will generate request handlers. So a request handler is simply a one-to-one mapping from an event type to what needs to be done to process that event. And then, of course, we have all the different Java API services that the request handlers can make use of to gather the data that they need to package up and send back to the UI for presentation. So down here, just as a reminder, is that we have a browser that's connecting the web UI. The connection is promoted to a WebSocket, and the data connection between here is using JSON as the protocol. So this is just flipped around a little bit. So we've got the web UI on the top left, the WebSocket on the right. And so requests may be made by a gesture from the user on the browser. And in this case, I'm just showing an example of a device details request. And so you'll see that this JSON is very simple. It's got the attribute event with the name of the event and the attribute payload with some arbitrary JSON object that is specific to the event type. so the code that's handling that type knows how to unpack the payload and do what it needs to. So the payload for a request is basically giving context for the specific event. So in this case, we're showing that this came from the topology view where a user clicked on a device, and then this event was sent down saying, please show me the data for device number 2. So what will happen is, basically using this as a key into a map of registered handlers, we'll pick the specific handler, and then it will then produce an instance of the request handler for that specific event type. That will make use of the services to get the data for that event, and then it'll use some custom written methods to take the data and generate the response. And so the response here, again, notice how it's symmetric. You have an event and a payload as the 2 attributes, where the event is the name of the event, and then the payload is specific to that event. And so that JSON gets shipped up to the browser, and then the JavaScript code that handles that will actually have a JavaScript object, which is essentially that you see. Yeah, okay. So in the example of clicking on the device, what will happen is, so the JavaScript controller code that was written to handle this registers. So yeah, I guess the client-side framework of the ONOS UI has a number of different libraries and services. I think they're exposed as Angular services. And so your little module that you write can say that it's dependent on specific services, one of which would be the WebSocket service. And so when your code is activated, one of the things that you do is you register event handlers for the events from the server to the client. One of which would say, I deal with device details response. So when this response comes back up to the client, your function is basically invoked with the payload as the function argument. And so then you can take that information. And as I was saying, in this particular example, what that would do is trigger the details panel being shown and then populated with the appropriate data. So you, as an application developer, can write your own UI extension. It would be part of a component. It would register during activate, unregistered during deactivate. If you're providing a single view, then you would have a single UI view token. You'd have your message handler and message handler factory that would generate message handlers on demand. They would have their own inner classes that would be request handlers to handle the event types that your view generates from user interactions. You would also have to provide HTML snippet, the JavaScript for the actual control, and possibly styling. And then also you would be providing these glue files. The glue files are really just a single line or two of the JavaScript inclusion or the CSS inclusion that you would expect to find in the head of an HTML file. Because we basically generate the index.html dynamically using servlets. It's not a static file. So the whole application page is stitched together at runtime on demand. And then, of course, your request handlers can use the appropriate services. So any service that is exposed in the Carafe container, you can make use of to service the request. So I just wanted to show you, as a developer, how this would be laid out in the directory tree of your source control. So under the Java branch, you would have your application package. You would provide, excuse me, you would provide a UI component Here I've just called it app UI component, but hopefully you would give it a more meaningful name. And within it, you would define one or more static inner classes of type UI view, and this is where your view ID is basically defined on the server side. You would also provide one or more message handlers, one for each view. And within the message handler, you would create your request handlers. So this is the Java side code where when an event comes from the client to the server, your code here would handle the request, taking the payload as context to talk to the services and provide the JSON response. On the client side, this would be under resources, app and view. This is just by convention. We've got resources app view and then a directory using your view ID that you declared here as the name of that directory. And then the HTML, JavaScript, and CSS would use that ID as the base name of the files. So the reason we're doing this is just by convention, using this technique, we can stitch everything together automatically. And then under a top level directory with your view ID, this is where you would house your glue files. So just to kind of finish up, we do have reasonably good documentation on the wiki. I won't say it's excellent, but it's reasonably good. So we have clickable links here in this presentation, which I will give you a reference to in a moment. But we also have some tutorials. So one of the things that we did was to create some Maven archetypes, where basically you put in 3 or 4 parameters and you can build a UI extension either as a new view or as a topology overlay within a few minutes. And so we have basically step-by-step tutorials for creating a custom view, for creating the tabular view, where you can make use of the libraries for generating your table views and saying which columns are sortable and so on. And then we also have one for creating a topology overlay. So the topology overlay allows you to do things like tell the topology that badges need to be added to these nodes, or these links need to be highlighted, or I want the labels on these links to be this text, and it can all be done dynamically. At the ONOS Summit this year, I did a 40-minute presentation, which kind of goes through some of this material and a little bit more. If I recall, I was actually walking through using the archetypes, so you may find that useful. So finally, if you don't do anything else, you might want to just scribble down this URL, and that will take you to this presentation online. So thank you for your time. If there are any questions, I'd be happy to field them. There you go. I hope you've found it interesting and didn't fall asleep. Yes?
Okay, one question. If there are many thousands of switches, is it possible that the web page for the refresh of the show will be very slow?
Yes, so that is one of the things that we're currently working on, is we're basically, the topology view that you saw here was the classic topology view, where you just have one flat representation of the topology. And what we're currently working on is topology view 2, which we're rewriting from the ground up. And this is, as Thomas was mentioning earlier, basically breaking down the topology into regions and groups and subgroups of devices. And so what we'll do on the topology view is we'll just show icons representing regions, and then and the linkages, or the inferred linkages between those. And then double clicking on a region would then change the view to what's inside that region. And then so you might see data centers or cities or something, and the linkages between them. I think we should also be representing linkages from within the region out to peer regions, so there'll be some visualization of that. But you'll basically be able to drill in to see it, maybe a data center rack. And then we'll use kind of the breadcrumb idea. So at each level, that you drill in, there will be a hyperlink so you can dive back out again.
Okay, good idea. Thank you.
Thank you. Yes?
Can you represent a multi-layer network with optical links and IP links carried by?
So the answer is yes, kind of, and yes in the future. And what I mean by that is the network that I have here is packet only. But one of the features that we added very early on was to change the perspective. Oh, apparently London's in the optical layer. Okay.
London is fun.
Yeah. I think it's because I changed the type of this to demonstrate that you can change the switch icon. So this is not recognized as a packet switch, which is why it's in the optical layer. But so you've got this kind of isomorphic, is that isomorphic? Oblique view. So in the new topology view that we're currently working on, we're actually looking to support multiple, more than just the fixed 2 layers. We'll see how that goes. Don't hold your breath, please. But this is the idea, is that you can switch views to see that. And if I remember, I don't know if it goes through London. Let's see. 1, 2. Why are you not selecting? There's 1, number of width, and okay, I'm not going to try it. I'm sorry. So yes, so that's one way of doing it. I think we also do toggle between the different layers. So packet layer, you can kind of fade things out at different layers here. And again, the ability to make things transparent or semi-transparent is something that your topology overlay can do. So if you're trying to highlight a particular part of the network, you can use APIs to tell the view which nodes to highlight and which nodes to suppress. And I think we'll probably use that mechanism for when we get to virtual networks, so that you can kind of visualize your virtual network on top of the actual physical network. Are there any more? Yes.
I work in white. For that kind of representation, because we are in project, we are looking for the implementation. We are very interested in the fact putting the switches in the wood. Indeed, for us, it would not be the switches, but the antenna.
Okay.
And also the friendly ladders. And I'm seeing there to do it. And I searched for around, I don't know, 4 or 6 months to make that and work to inject that the JSON with the
Do you mean the images for the icons, or do you mean adding the?
You have the switches there.
Oh.
Already placed somewhere with the latitude and the longitude.
Yes. Yes.
I know I can have the longitude and latitude of all the antennas in the farm, for example. And I want to put them when I have ONOS. I want to put already them and not as I do now.
Oh yes, yes. So yeah. I can probably
remember. So the UI is documented actually excellently, but this is not part of the UI. This is part of the network configuration subsystem, which is unfortunately not documented excellently, and therefore you did not find it. And, yes. And so, but yes, it's very possible, very simply, to be able to inject this information. We have some samples actually in the source code that show how to do this. So very simple JSON. So good news is that it's easy to remedy. That it is easy to fix. Okay. Yes. And
yes.
Maybe tell me what is the path.
Yes. Under test.
So if I just pull this one up, you see here that you can basically annotate the devices. This is the device ID, and then for the net configuration, we have different levels of data. So this is the basic level, and this is where I'm giving the friendly names for the devices, and then describing the latitude and longitude, just as double numbers. And I think this one, if I was to scroll this way, is the one which is choosing an alternate icon to use for that specific switch. That's why it was different to the others. So basically, this data is injected into the network configuration subsystem that's distributed across all the members of the cluster. And then when the UI is asking for the data for the topology view, the backend code is basically accessing this information and then shipping that up with the data that it's sending. And then for the JavaScript, as I said, we're using TopJSON maps to be able to use projection. So there's a function that will take longitude, latitude, and convert that to the appropriate XY for the map that's projected onto the.
Tools, test, topos. Tools,
Oh yes, tools
test,
test topos.
topos.
Okay, thanks everybody.